All right, here's a quick review of special right triangles. You'll remember these from geometry, the first of which is called the 45-45-90 triangle, or the isosceles right triangle. If a triangle has two angles that have the same measure, and in this case, when we look at this triangle here, we see 45 and 90, and the other triangle, the angle must be 45 since the angles have to sum 180. Then if two angles are the same, then two sides will be the same. Now, for our purposes, we can make up some sides, and then we're going to use similar triangle ratios to solve for missing sides in unknown triangles. So for instance, for this triangle right here, we do know that the two sides that are opposite the 45s have the same length, and I'm just going to call them 1 because they're equal and 1's an easy number to work with. Since we know that, we can figure out what the hypotenuse is by using the Pythagorean theorem. 1 squared plus 1 squared is equal to c squared. Since our hypotenuse is the longest side, and that's the missing side here. So 1 squared is 1, and that gives us 2 is equal to c squared. So c must be the square root of 2. And so every 45-45 right triangle will be similar to this one right here. Let's put that to use. In this example here, we have another 45-45 right triangle because we have angles that are given at 45 and 90, and the missing angle must be 45 since the angles sum to 180 degrees. And we know that since it's a 45-45-90 triangle, that it's similar to the one above. So what I'm going to do is set up a similar triangles proportion, and then we can cross multiply to solve. So in the triangle above, we have the square root of 2 as the hypotenuse. In the triangle below, we have 6 as the hypotenuse. In the triangle above, a side opposite a 45-degree angle is equal to 1. In the triangle below, a side opposite the 45-degree angle is x. All right, let's take this proportion now and solve it to find x in this triangle. So I'm going to cross multiply the square root of 2 times x, or x times the square root of 2, is equal to 1 times 6, which is 6. Now, in order to solve, we need to undo the multiplication by dividing by the square root of 2, and that will give us 6 divided by the square root of 2. But as you remember, we can't give a simplified answer with a radical in the denominator. So we're going to rationalize this by multiplying by square root of 2 over square root of 2, and we'll get x is equal to 6 times the square root of 2 over the square root of 4, which is 6 times the square root of 2 over 2. And 6 divided by 2 is 3, so our final simplified answer here is x is equal to 3 times the square root of 2. All right, here's another example with a 45-45-90 triangle. So we know that this one must be 45-45-90 because we have a 45 and a 90, and that leaves 45 degrees to complete the 180 degree total for the three angles of the triangle. And then I'm just going to draw my similar triangle over here with the same orientation. It'll be 45-45-90, and the two shorter sides will be 1, and the longer, or the hypotenuse, will be the square root of 2. So if we set up a similar triangles proportion, x in the first triangle over the square root of 2 in the second is equal to 7 times the square root of 3 in the first over 1 in the second. All right, I'm going to take and cross multiply. So x times 1 is x, and then the other cross multiplication that it's equal to is 7 times the square root of 2 times the square root of 7 times the square root of 3 times the square root of 2. So all we have to do here is multiply. And there are three things to be multiplied, and that the number outside the radical cannot be multiplied by the numbers on the inside of the radical. But we can multiply these two square roots together. The square root of 3 times the square root of 2 is the square root of 6, so x must be 7 times the square root of 6. All right, our second special right triangle is the 30-60-90 right triangle. And in order to find out what the sides of what I'm going to call the basic one that we're going to compare against every other 30, 60, 90 triangle so that we can write a proportion which we can solve to find a missing side. So in order to find those sides, I'm going to remember that this is a half of an equilateral triangle. Okay, and if we draw the rest of the equilateral triangle, it's a mirror image of the 30, 60, 90 triangle. And what you'll notice about this triangle right here is that all three angles of the equilateral are 60. That means all the sides have to measure the same. All right, and what we want to do is kind of a clever choice of sides here. I'm going to label the very shortest side in the 30, 60, 90 triangle as 1, because 1's a really easy number to work with. That means this other piece over here is also 1, which means that that whole side measures 2. And if that whole side measures 2, then every other side of the equilateral triangle measures 2. And the only thing that's left to find is this missing piece in the middle, which I'll call h for height. Okay, so let's take our right triangle, which I'm going to just draw separately for clarity here. 30, 60, and 90, and we've got h, 2, and 1. Now 2 is our hypotenuse, so h squared plus 1 squared is equal to 2 squared. So h squared plus 1 squared is 1, and 2 squared is 4. Subtract 1 from both sides, h squared is 3, and h is equal to the square root of 3. So the basic triangle for a 30, 60, 90 triangle has sides of 1, square root of 3, and 2, where 1 is opposite the 30-degree angle, the square root of 3 is opposite the 60-degree angle, and the largest side 2 is opposite the 90-degree angle. All right, let's take a look at example 3. We have a right triangle in the picture. We have a 90-degree angle. We have a 30-degree angle that are given. That's 120 degrees. That leaves us 60 degrees for the missing angle. So we do have a 30, 60, 90 triangle. And so we're going to compare it against the one that we just worked with up here. And so in our triangle above, the square root of 3 is opposite the 60-degree angle. And in our triangle below, x is opposite the 60-degree angle. In the triangle above, 2 is opposite the right angle. In the triangle below, the square root of 10 is opposite the right angle. So we just have to match up those corresponding sides. Now we can cross multiply, and when we cross multiply here, we're going to get 2 times x is equal to the square root of 3 times the square root of 10. The square root of 3 times the square root of 10 is the square root of 30. Now we can divide both sides by 2, and x is equal to the square root of 30 divided by 2. That's not going to simplify because the number on the bottom is a whole number, and we have a square root on the top, so we can't simplify using common factors.